This question, we're taking the limit as x goes to infinity of this function. Actually, let's start up here. And first step is you could just plug in infinity. It's not going to work. But let me just do it. So you plug in infinity here, infinity there. Basically, you might be aware we're going to infinity. We can just do the most powerful term, square root of x squared. So basically, long story short, it's going to be infinity minus infinity because this whole part's infinity. Take away infinity. You might say, well, that's zero. Well, no, you can see the answer is not zero. And the reason you can't say infinity minus infinity is zero, it's unclear because the problem is it depends how fast they're going to infinity. Like if you send two rockets up into space, right? If one's going way, way, way faster than the other, the gap between them will keep actually growing, won't it? Right? If they both launch at the same time, but this one's going twice as fast, he'll be here, and then he'll be here, and he'll only be here. See, the gap between them is growing, not shrinking. The gap, the subtraction, the difference between the infinities is not headed to zero. It's actually going to infinity. So my point is, it's just unclear. We can't say infinity minus infinity is zero because it depends on the rate and how fast they're headed towards infinity. So, okay, well then what? So we can't do that. What do we do? We'll come back here. You know what we really need to do is we need to make it a fraction. So I'm going to make it a fraction. I'm going to put it over one. That doesn't change anything, right? It's still the same thing it was. Putting over one doesn't change anything. And I don't know if you remember, but whenever we have roots added and subtracted, you know what we want to do? We want to do the conjugate. We do that all the time in math and science when we have a root added or subtracted to something. Now, what's this a technique you want to get used to? We use it a lot. What is the conjugate? It means same exact thing, but opposite sign in the middle. So right here it's going to be plus x. And whatever you do to the top, you have no choice, of course. You got to do the same thing to the bottom, right? Because you can't change the fraction. Got to do the same thing top and bottom. So you see what I'm doing? I'm multiplying top and bottom by the same thing, which is the conjugate means opposite sign in the middle, right there. So see how that minus sign became plus. And we got to do the same thing, top and bottom, so we don't change it. That's called the conjugate. When we ever have a root and something added or subtracted, what cleans it up is multiplying by that same exact thing, opposite sign in the middle, called the conjugate, top and bottom. Here we go. It's going to be a bit of a mess, but we can do it. We're calculus students. All right. So how you want this is all one term, second term, one term, second term. So I'm gonna FOIL these out. So this whole term goes there. What is root of x squared minus 10x plus 1 times itself? It just removes the root, right? You know that, like root 3 is root of 9, which is plane 3. So if you have two threes in a root, they multiply and the root goes away. So the same thing is, if that's true for plain old numbers, it's true for big old fancy x expressions. The root of the same thing twice, the roots just cancel. And so we just get x squared minus 10x plus 1. All right, that's nice, huh? And then it goes there. So we go, oh, okay, well, then that x is just going to go to the front. And we'll have the root of, in fact, how about I color code just so your eyes can see it better? It's going to be, here, I'll keep it the original. This will stay green, just green there. And then I'm going to go to, oh, come on, root tool. Root of x squared minus 10x plus 1, right? They multiply. And now, it's this guy's turn. He's going to go boom. So that'll be minus x, and we'll have the root of x squared minus 10x plus 1. And then finally, it'll go there, minus x squared all over. What are we do on the bottom? On the bottom, don't do anything. Just, 1 times this. It's not going to do anything, right? So it's just going to be square root of x squared, whoops, minus 10x plus 1 plus x. Scribble there. Okay. You okay with that top? That's where people get tripped up sometimes. See, so the first one went to both. Root times root, remove the root. and then the root times the plus x, that's plus x root. And then he's done, and now it's this guy's turn. He went there, it's minus x times the root, and then he went there, minus x times x is minus x squared. Okay, now what happens here? Well, you see these cancel, right? Because they're the same thing. One positive, one negative, same thing. And x squared minus x squared cancels. Isn't that nice? Happy days are coming again. Happy good things are happening here, right? So now we bring it on down. We have the limit as x goes to infinity of what? What's left? Minus 10x plus 1. Oh, that's it. That's super nice, isn't it? And on the bottom, we've got square root of x squared minus 10x plus 1 plus x, right? Okay, now what can we do with that? Well, so now if you plug in, you're going to get infinity here, you're going to get infinity there, and infinity there. You may say, well, it's infinity over infinity. It's one. No, it's unclear. It's unclear. So remember what we do when we have the limit as x goes to infinity of a fraction, of a fraction. What we do is we grab, so you need to know the game plan for that. It comes up a lot. You grab only the highest power term on the top numerator and the bottom denominator. So that's all that matters. This guy, and this guy, they'll be separate because they're really the same power. Square root of x squared is really x to the first, like that guy. They're tied, so they'll both stay. That making sense? So you get rid of the lower powers, in other words. So on the top, then, we're just going to have minus 10x because this guy doesn't matter. Well, since we're going to infinity, you see, that's just, when we didn't do that back, we did limits early in the beginning of the course. Yeah, because we weren't going to infinity. That's the whole point of this section is we're headed to infinity now. What happens when you go to infinity? Different kinds of things happen. Specifically, you're going to plug in to x a million, a billion, a trillion. You're not plugging in like two or three. You're not going to two or three or -2 or -3 or something like that. You're going to infinity. So if you're plugging in infinity, 10 times infinity is so much bigger than 1. Just get rid of it. And infinity squared, like a million squared, is so much bigger than just 10 million. A million squared is actually a trillion. That's much bigger than just 10 million or 1. So you just get rid of the lower power terms. So this becomes square root of x squared plus x. Now, why do they both stay? You might say, well, these lower power. No. He's the same power as, because this is a root of x squared, which is the same power as x. So they both stay. Okay. Now, at this point, you might say, well, just make that x and x plus x. Well, kind of. Almost. Almost. Let's do this. Here's the deal. Earlier video, maybe you saw that it's important to know that the square root of x squared is not x, it's absolute value of x. Absolute value of x. It's not just x. It's not just x. That's what a lot of people think, right? That's what we did in your algebra days. You're just doing algebra pre-calc, so we go, square root of x squared, just call it x. We're being casual back then. Now we got to be more precise and exact. Why is it that? Well, just think about it. Let me just prove it to you. What if you plug in x is -3? Let me just prove it one more time real quick. -3. Oh boy, I'm just getting too scribbly here. What if I take the square root of -3 squared? What happens? It's square root of 9, right? -3 squared is 9, which is 3. See how it turned that -3 into +3? +3, right? So that proves that what square root of x squared does is its absolute value. It makes it positive. So it's not just x, it's absolute value of x. Okay, so back to it then. So then we have, okay, so this is the limit. This goes to infinity of, so on the top, we still have -10x. On the bottom, we have the absolute value of x plus x. Okay, the absolute value of x plus x. Now, what does that mean? Well, we're going to positive infinity here. So then the absolute value, we're just plugging in positive numbers. So this is really just going to be minus 10x. This is just going to be plain x. You see that? It's just going to be plain x there. Let me do a better job on that. It's just going to be plain x because we're going to positive infinity. In a minute, we'll do the other part going to negative infinity. Then absolute value will not be that. But if you're just plugging in positive numbers, absolute value does nothing. It's just x. Okay. So what then? So then we end up with negative 10x over what's the bottom? X and x is 2x. X is cancel. Negative 10 over 2. It's -5. And there's our answer. That's the answer to the first part, -5. Now, on the second part, won't be much work because it's almost the same. So in part two, let me separate the work out here. So then in part two, we're taking the limit as x goes to negative. Everything will be the same down to here. So I'm just going to grab it from there. I'm going to go, okay, now we have negative 10x over absolute value of x plus x. At this point, since we're going to negative infinity, what just happened there? All right. Oh, oh, sorry. There we go. At this point, since we're going to negative infinity, I can't say absolute value of x is just x. No, 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 no. What's going to happen? Do you remember what absolute value of x is? Absolute value of x, what does he do? He's x, he just leaves it alone when x is positive, but he's opposite of x when x is negative. Is that making any sense? I know that's confusing. You probably seen it earlier, and you really need to understand it at this point in calculus. Think about it. Think about it for a second. What happens when I take the absolute value of a number like 30? Well, it's just 30, right? What happens when I take the absolute value of something like -2? It makes it positive. How does it do that? It puts another negative on the front, making it +2. So do you see the point? When you put a negative number inside of an absolute value, it puts another negative on the front of that number, right? So call this x, it just put a negative in front of our x, changing it to positive. Whereas if the x was already positive, it just left it alone. That's what this is saying with letters. If the thing is already positive, it just leaves it alone. But if the thing is negative, it puts another negative in the front. Like what did it do to -2? Put another negative in the front, two negatives made positive. So therefore, this is going to become negative because x is what? X is negative. So this absolute value of x becomes negative x. You see. You see that? That's the point. See, up here, the absolute value of x just became regular x because x was positive. X was positive. We're going to positive infinity. So then the absolute value of x just leaves it alone, right? If you have a positive number and absolute value, it just leaves it alone. But here we have a negative number we're going to plug into the absolute value for x. When you have a negative number inside absolute value, what does it do? It puts another negative in front, making it positive. It's negative, the number you have in there. So it's this. Okay, so then what? So then that is going to be, trying to keep all the colors here. Negative x plus x, that's 0. That's 0. Oh, so that is 0. Right. So right there, just going to cancel out. So what does that mean when, and then we're going to plug into the top up there, negative infinity. So we're going to have -10 times negative infinity over 0. Two negatives make positive infinity over 0. What does that mean? That's just big old infinity. That's just big old infinity there. There we go. Now you might wonder wait, why is 0 in the bottom infinity? Remember, it's where it's where you're headed. The bottom is headed to infinity, right? The bottom is headed to infinity. It's getting closer and closer to infinity because as the bottom gets close to 0, you can prove it this way. If you have like 7 over 1, that's 7. Then if I go 7 over zero point 0.1, that's 7D, right? Like in other words, how many how many dollars go into $7, right? Because remember, fraction always means, let me just prove to you this is true. So go 7 times. Now this is 10 cents. How many dimes in $7? Well, 70 dimes. Okay, now what if we go, okay, now so I'm letting the bottom go to zero. How many pennies? That's 1 cent in $7. There's 100 pennies in every dollar. That'd be 700. See what's happening? As the bottom gets smaller and smaller and smaller, headed to zero, as the bottom heads towards zero, these numbers are getting bigger and bigger and bigger. They're headed towards infinity. So as the bottom of a fraction heads towards zero, that makes so they're both doubly making this thing go to infinity. And so there we go.